Okay, so introduction muna tayo for the partial differential equation. Kung hindi medyo familiar dito sa partial differential equation, different siya from the ordinary differential equation. So yung definition natin for the partial differential equation, or also called as the PDE, it is an equation that partial derivative of some unknown function. So meron tayo ditong given na unknown function. So yung unknown functions na yun yung gagawa natin ng solution. And then in comparison to the ordinary differential equation or the ODE, it contains yung one variable lang kasi when it comes with the ordinary differential equation. Pero for the partial differential equation, it contains differentials with respect to several variables. So yun ang pinagkaiba nila. Again, for the ODE or the ordinary differential equations, one variable lang siya. And for the partial differential equation, it contains several variables. For example, ang variable natin for the ODE is x. And then for the partial differential equation, it can be x, y, or other variables pa. Okay, so for this discussion, our goals are the following. So first is to formulate PDE. Paano tayo makapag-formulate, and then also after natin makapag-formulate, we need to solve yung PDE natin and also to study the solutions. And then I also include here yung mga notations na ginagamit natin to solve the PDE. First is yung ano ba yung mga letters yan or yung variables na usually ginagamit natin for the partial differential equation. We have here yung x, y, z, and then the t, which are the independent variables. And then we have here the x, y, and z. It represents naman yung sa spatial or about sa space. And yung t natin or the variable t is for the time or nagre-represent siya ng time natin. So with respect to time again, ayan. We have here in derivatives with respect to space and with respect to time. And then we also use dependent variables. Yung dependent variables natin dito is yung u and v. And then we also use subscript for partial differential equation. So yung we have here, for example, is the u sub x, equivalent siya sa derivative of x with respect to u, and we also have yung u xt, so second derivative with respect to t and x natin. Okay, so ang example natin dito, yung first example natin is all about the heat equation. We have yung sa heat equation natin as formula daw na we have yung u sub t natin and equal siya sa u sub x. Yung x natin is dalawang x lang siya. So yung t dito is nagre-represent siya as time and yung x natin is sa space. So for example, hanapin natin yung sa solution nito. We have yung problem natin, which is we have yung u is equal to 1 over 2x squared plus t. So i-check natin if ever na ito is correct with the problem natin. Okay, kung with respect to t, since ang kukunin natin dito is the first derivative, let's say ito yung u sub t natin and kukunin natin yung first derivative, kapag kinuha natin based dito sa equation natin, since we have yung x dito, so equivalent na lang naman nito is 0 kasi with respect to t siya. And then, derivative ng t, kapag mayroon tayong ganito na equation or yung t lang is equivalent lang siya sa 1. And then, well, for the u naman natin with respect to x naman, yung x yung gagamitin natin for the first derivative, of course, dito is gagamit tayo ng power rule. Kapag ginamit natin yung power rule, ang magiging value na lang natin is x. Kasi di ba kapag nag-power rule tayo, itong exponent natin is mapupunta siya dito. So magkakaroon tayo ng 2 over 2. So equivalent lang siya sa 1. And then yung exponent natin is n minus 1. So equivalent na lang siya sa x here. And with respect to x again, yung t natin is equivalent na lang siya sa 0. And then, since ang kailangan natin dito, sabi natin sa equation natin is dalawang x or equivalent siya sa second derivative. Yung first derivative daw natin is we have yung x. And then for the second derivative, i-derive lang natin yung value ng x. So we have naman yung value as for the derivative of x is equivalent lang siya sa 1. So therefore, yung value natin ng u sub t which is equivalent sa 1, and yung u sub double x natin na to is equal din sa 1. Ibig sabihin, yung u sub t natin is equivalent lang dito, which is yung heat equation natin. Dito naman sa equation natin, halos kadugtong lang siya ng una nating problem. Pero we have here naman, u is equal to the e raised to ax plus bt. Ang hinahanap naman natin dito sa problem is yung a at saka yung b natin sa value natin ng nitong problem natin. So for this problem, kunin muna natin yung u sub t, and then kukunin natin yung u sub x, and then kunin natin yung u xx or sub xx. Yung first natin with respect to u sub t natin, so we have here yung equal siya sa e raised to ax plus b raised to t. So kunin natin yung derivative. For the derivative of e raised to ax, itong mismong ax natin is equivalent lang siya sa 0. And then for the bt, derivative nito is b. That's why we have here yung value ng b kasi, di ba, ganun siya magde-derive pag meron tayong e. And then for the u sub x naman, since based to sa u sub x, yung bt natin dito is equivalent na siya sa 0. And yung derivative ng ax natin is equivalent lang siya sa a. Therefore, yung u sub x natin is equivalent sa e raised to x plus bt times yung a natin. And kukunin natin yung second derivative, which is, again, based dun sa mismong exponent natin. Itong bt is 0 pa rin. And then again, dito is meron naman tayong a. Kaya meron tayo dito a squared. Therefore, for the u double x natin, sub double x is equivalent sa e raised to ax plus bt times the a squared. And then, simplify lang natin based sa formula natin na u sub t is equal to u double x. We have here for the u sub t is the e raised to ax plus bt times b. And then for the u double x natin or yung sub x natin, we have e raised to ax plus bt times yung a sub a squared natin. And then, syempre, if we divide this both side with the e raised to ax plus bt, ang magiging value nila natin, ito is makakancel na siya. That's why we have here na yung b is equal to a squared. And so, we have naman here yung mga classifications ng sa partial derivative natin. So, we have yung wave equation, or ang almost itsura ng graph nito is hyperbolic. And yung for the Laplace equation natin. So ito yung mga formula na gagamitin natin or yung equation natin na gagamitin for the partial derivative natin. Ayan. We have here yung sa Laplace naman, yung graph naman nito is elliptic. And for the heat equation is para siyang parabolic naman. For the wave equation, ito yung formula for the wave equation natin. Ang formula natin is we have the u sub t or yung double t natin, which is represents to ng time. And for the u sub double x naman natin dito is for the space naman siya or spatial coordinate. And ito is nag-start siya noong 1940s with this siya yung nakatuklas nito, which is D. Alembert. And for ang example natin dito is the water wave and also the string. So yung dito, meron lang akong pinakita dito na graph. Pero, yung graph na to is we have isang graph dito, which is yung wave natin, and another graph na to is individual wave lang siya. And yung pinapakita dito, yung mismong vertical axis natin is the u variable. Yung u variable natin. And for the horizontal axis naman is the x variable. And nagva-vary to sa time, which is yung t natin, yung t na to. Ang pinapakita lang naman dito sa graph natin, imagine natin meron tayo, nasa dagat tayo, tapos may wave. Yung wave na to is pwede siyang bumaba, tumaas, pwede na naman siyang bumaba and tumaas. Same lang din dito sa graph natin na isang wave na to, pwede siyang bumaba, tumaas, and then bababa siya, pwede rin tumaas. So habang nag-i-interact or nag-interact yung dalawang wave natin, nag-grow siya and pwede rin siya mag-shrink. And then, another example is yung sa string natin, sa gitara or yung sa guitar natin. For example, nagpa-pluck tayo ng mismong string ng gitara. So, kapag plinak mo siya, pwede rin siya yung mag-wave. Mag-wave din yung mismong string niya. Halos parang din sa sa ito din, yung sa wave na to or sa water wave natin. Halos same lang din siya na pwedeng yung mismong kapag nag-pluck tayo, pwedeng bumaba siya or pwede ring tumaas. Ganun yung sa example for the wave equation. And for the Laplace equation naman, we have naman dito yung formula natin, which is yung u sub double x natin plus yung u sub double y natin, or equivalent din siya sa 0. So nag-originate siya ng 1980s and based kay Laplace. And yung example lang natin dito is we have naman daw yung sa thermal equilibrium. Yung thermal equilibrium is yung heat flow of energy from a higher to a lower temperature. So ang example lang natin dito is yung the exact shape of the membrane inside yung sa wireframe. So for example, we have here naman yung wireframe and pinakita lang naman dito sa mismong picture natin, which is for the thermal equilibrium, yung hottest part natin is yung red and hanggang sa yung coldest part natin is itong part na to. Yung siya pinapakita. From higher temperature, which is ito, to lower temperature. And then for the heat equation naman natin, halos almost the same lang din sa discussion natin kanina, which is yung example natin, yun nga, yung heat equation natin na na-prove natin, na yung formula natin is U sub T is equal to U sub double X natin, which is nag-start siya noong 1800s by Joseph Fourier for the purpose of modeling how a quantity such a heat diffuses through a given region. So dito, meron lang tayong pinapakita na example natin is meron tayong rod. Yung rod na yon is pinainitan natin siya sa middle na part. Kaya yung mismong hottest part natin dito is itong part na to, which is yung red again natin, and yung dalawang side natin is yung coldest part. Kung pinainitan natin siya sa middle, syempre ito yung pinaka mainit na part ng rod natin. And then habang tumatagal siya, after natin siyang painitan, so itong part na to is lalamig pa rin siya, pero unti-unti. So ito yung pinapakita dito sa next picture natin. And it also the same with this graph natin here. For example, di ba? Ito yung graph natin. Dito kasi sa kabilang graph natin, ang pinapakita is true color lang siya. Pero ito is true graph na siya. Yung for example, ito yung rod natin, itong line na to. Itong line na to. And yung middle part, yun yung pinainitan natin. So kaya medyo naka-high to. Itong part na to, may high temperature. Habang tumatagal to, habang after natin painitan siya, unti-unti siyang magko-cool down. Kaya yung graph natin dito na pinakita sa isa is pababa na yung mismong temperature natin or yung mismong meron tayo dito pinapakita na heat distribution. Okay. And ito lang yung part ng engineering partial differential equation natin. Almost the same lang din siya din sa mga formula natin kanina, pero medyo medyo iba lang yung way ng pagpo-formulate, pero same lang naman siya. Yung first natin dito is the wave equation, which is yung diniscuss natin kanina. Ang pinapakita lang dito is yung sa motion, which is yung formula natin ay ito daw. So we have here yung the second derivative of u with respect to x, equal lang siya sa 1 over c squared, derivative of u over p squared. Where yung c natin, c squared is equivalent to t over the rho natin, or itong symbol na to. With t being the tension of in a string and p being the mass or unit length of the string. So later on, magagamit natin yung mga formula na given natin dito. And then next natin dito is the heat conduction equation. So for the heat conduction equation naman natin, we have yung formula as the second derivative of u over the x squared equals sa 1 over c squared derivative of u over t natin or with respect to t. And for the formula naman natin for the c squared, we have here yung h over the sigma times the rho, with h is being the thermal conductivity of a material and yung sigma natin is the specific heat of the material, while yung rho natin is the mass over unit length of material. And then for the Laplace naman daw, For the Laplace equation, ito naman yung formula natin, which is we have yung sa second derivative of u with respect to x plus the second derivative of u with respect to y plus the second derivative of u with respect to z equals sa 0. Yan yung mga formula na gagamitin natin. And then for the last is the transmission equation. For the potential U in a transmission capable in the form of this equation, dito naman, we have naman yung constant. Kung kanina wala tayong mga constant value, dito meron tayong A, B, and C. Nag-represent siya as the constant. We have here for the formula as second derivative of U over X is equal to the A times the second derivative of U with respect to T plus B times first derivative of U over T plus CU. Yan naman yung formula niya. For the separating of the variable, na to, ang pinakita natin dito is for the example is the wave equation or the trial for the wave equation. Later on, kung i-recall natin, medyo kailangan din natin dito yung formula natin for the homogeneous equation natin. Yung discussion for the homogeneous equation. So we have here na yung let u x t is equal to x, small letter x for or open and closed letter x, t, then t where x of x is a function of x only and t of t is the function of t only. Be a trial to the wave equation. Again, ito yung wave equation natin, which is we have the second derivative of u over x is equal to a over c squared, second derivative of u with respect to t if the trial is simplified to u is equal to xt. So dito ang pinapakita natin yung mga formula pa lang na gagamitin natin for the wave equation. Let's say we have na yung formula ng simplification natin. For the trial solution nga natin, we have u is equal to xt, and then for the first derivative daw natin of u with respect to x, we have naman yung xt natin for the first derivative, and for the second derivative naman, we have here yung xt pa rin. So ang pinagkaiba lang naman nila pag yung pwede kasi tayo magsulat ng derivative kung either gantong way or meron tayong gumagamit tayo ng apostrophe. Pag first derivative is we have yung isa lang siya. Pag second derivative naman is dalawa yung ginagamit natin. And then also for the first derivative of u with respect to t, ganito naman siya. Yung naka-first derivative natin is yung t. So meron tayo lang dito na first derivative, yung first na isa lang yung apostrophe natin. And then for the second derivative naman natin of u with respect to t naman, so dito mapapansin mo, yung t naman natin is naka-dalawang apostrophe naman siya. So, or yan yung formula natin. Ayan. So, isa-substitute lang natin based din sa given natin kanina or yung mga formulas natin na binigay kanina. So, we have here the substituting into the partial differential equation for the second derivative. Again, yung formula natin for the second derivative of the wave equation is 1 over c squared, second derivative of u over t. So, we have here yung second derivative of x times t is equal to 1 over c squared times x times yung second derivative of t. And then, separate natin yung variable natin. Ito na yung magiging formula natin. So, itong left side natin, we have yung dalawang x natin. And for the right side is we have yung dalawang t natin. We have here the second derivative of x over x is equal to 1 over c squared times the second derivative of t over ng t. Dito lang siya. Dito lang sa formula natin na to. Sinimplify lang natin or sineparate lang natin yung variables. And then gumamit lang tayo ng mu. Mu for the constant value, which is equivalent lang siya sa x squared, yung second derivative of x over the x is equal to 1 over c squared times the second derivative of t over t. And then after nun, yung mu natin is a function only. So ito siya. It must be a independent of t. And then for the function of t, ito naman siya, and must be independent of x. Kasi dito, sa given natin, ito is function for x lang siya, kaya dapat independent siya for t. And then for this one naman, since function naman siya ng t, dapat independent siya kay x. If mu is independent of x and t, it can only be constant. So, constant siya as given kanina natin. And then dito, sinimplify lang natin to get yung value natin for the second derivative of x, which is equivalent lang siya kapag kinuha natin yung second derivative based dito sa formula natin na mu is equal to second derivative over x, it can be written as this, where we have the second derivative of x is equal to mu times the x, or we can also write it this way, na we have na yung sa second derivative minus the mu of x is equivalent lang siya sa 0. And then for the t naman, we can write naman ng ganito, where based dun sa formula natin na mu is equal to 1 over c squared times the second derivative of t over t. Kapag kukunin daw natin yung second derivative, based dito sa equation natin, we can write it as t, yung second derivative is equal to c squared times mu times yung t natin. Ito lang siya. And then, we can also write it this way, na we have the second derivative of t is equal minus second derivative of t minus c squared times the mu times yung t natin. Equivalent lang siya sa 0. So, medyo marami yung formula natin, no? Dito naman, we have daw yung sa ordinary differential equation lang siya na pinapakita. Pero, yun, nadedepende yung mu, either pwede siyang maging greater than 0, or we can say na yung mu natin dito is equivalent sa 0, or yung mu natin is less than 0. And then, we have na yung sa formula. Ay, wait lang po. Ayan. So, yung we have na dun sa formula kanina na mga diniscuss natin, itatry natin siyang gamitin dun sa problem natin for the differential equation. Yung, kung marirecall mo, based dun sa discussion natin before ng homogeneous natin. So, dito, di ba, meron tayong classification for the general solution natin. For example, ma-categorize natin yung before, yung sa m natin as real number, and then kapag different yung mismong value ng m, or yung real number natin is pareho yung value ng m natin. So, doon natin makikita yung mismong answer natin for the general solution. So, yun, medyo i-recall lang din natin for the homogeneous, and then application lang din dito for the formulas. We have na yung problem natin as yung second derivative daw natin, second derivative of x minus the 4x is equal to 0. And yung next natin na isa-solve is we have yung t minus 4x is equal to 0. For the first problem, equation lang naman to. Halos same lang din sa discussion natin before para makuha lang yung general equation. General solution. So we have yung x nga, second derivative minus the 4x. And then, recall lang natin based sa discussion natin before ng chapter 50 for the homogeneous. So kukunin lang natin muna yung D, di ba before yung D natin, and then after nun, kukunin natin based din sa D yung auxiliary equation, yun yung dati sa discussion for the homogeneous. And then for this problem, ayun, kunin lang natin yung auxiliary equation. Based dito sa problem natin na to, we can consider na yung m natin, m squared minus 4 is equal to 0. And yung m squared natin is equal sa 4. So, itong problem na to, pwede tayo makakuha dito, or ditong equation na to, pwede tayo makakuha na either plus 2 or yung m natin is minus 2. And then, based lang dun sa mismong category natin, dun sa dating discussion natin, hanapin lang natin siya kung saan siya magpo-fall dun sa formula natin. And then, for this problem, yung una natin is the alpha, di ba, before, and itong negative 2 natin is for the beta. Therefore, yung value lang natin dito is we have yung x is equal to 8 times e raised to 2x plus be raised to negative 2x. And then for the b naman natin, yung b is, yung problem daw natin dito is we have the second derivative of t plus 4t is equal to 0. So recall lang again natin yung dati nating ginagawa or yung way natin for getting the auxiliary equation. Yung before kasi, di ba, kunin lang natin muna yung d form, And then after natin kunin yung d-form, kukunin na natin yung auxiliary equation. Dito, pwede natin siya ma-simplify as we have yung m squared plus m equal to 0. And then example natin is we have the m squared equal to -4. And then for this value, category nito before is the letter C, which is yung value nga natin is hindi na natin makakuha yung mismong value. So yung m natin dito is either plus minus j and then yung 2. And then based dun sa general solution natin, ito yung magiging formula natin. Then simplify lang natin, which is yung t natin is equivalent to e raised to 0 times the a cosine 2t plus b sine 2t, or equivalent lang siya sa a cosine 2t plus b sine 2t. Any questions?